Okay, today we're going to look at scale factor, dealing with perimeter and area of shapes. I want to talk really quickly about how to find the perimeter. How would you find perimeter of a rectangle? Yeah, you say length plus width plus width. Another way to write this is perimeter is 2 length plus 2 width. Um, Something else I want to look at is just how to find the area, and that's just going to be length times width. So I think that's pretty important for us. Um, you have some shapes up above. I want you to realize that yours is not in color necessarily, and they're kind of ugly colors anyway, the way this looks. But I just want you to see that they are partitioned into different sections, where like part B, it's actually all these squares. This is the entire rectangle. It goes all the way over to 0, 0. This one here, C, is this big right here. D obviously is the entire thing. Everything starts at 0, 0 and goes over, so you can find the lengths and the widths of things really easily. Like part E is actually 14 long by 10 high. What I'd like you to do right now is just to fill out the width. Again, the width is going to be shorter than the length. The length is always the longest side. So fill out the length, the width, find the perimeter, find the area. I want you guys to start off with that right now. I think. Okay, we're back here. We've just filled out some of this chart. I hope I filled it out correctly. If you know something I did wrong, let me know. I was just trying to do this all in my head here. For part B, it is 4 units sort of high by 6 units across here. So if you were to add this up, that'd be 4 plus 4 plus 6 plus 6. That should be 20 units. And if you were to find the area, it's 24 units. Is that what you guys got? Okay. If I read the next ones, is it 6, 8, 28, 48? 6, 9? Oh, that makes much more sense. Good. Well, that is going to change my answer. So this is definitely a 9 here. What does that change this to? That'd be 30. That'll change this guy to 54. Okay, thanks. Let's see. Next one is 12. Probably the last one here, I probably messed up on this one. This is probably also 15. Let's go with D is D, 8, 12, 40, 96. 8, 12. And then E is going to be 10, 15, 50. And then let's see, what do we have? 150, something like that. Is that where we're at? 10, 15, 50, and 150. Okay. Kind of an important thing to note. Again, you guys are getting really good at units, and this is the reason I've been harping on units for a long time. All of these units are one-dimensional, correct? Just units. All of these are two-dimensional. They're square units, so that's the difference. These are all one-dimensional. These are all one-dimensional, one-dimensional, and these are the only ones here that are 2D. Okay, everyone has those numbers, right? Okay, I'm going to look at the next part now. You're going to have to help me with the numbers. When we're looking at scale factor, we're going to fill out this chart as well, but I just want you to, we're going to go through one of these by ourselves here. It says A over B, so the rectangle. The scale factor, what we're going to do is we're going to pick some of the sides. So which part from A is going to be 2? Is it the length or the width? That's the width. So we have the width. The width from B, what's the width from B? 4. Okay, that's how we got 2 over 4, so we just use the widths, which is fine. That's going to be 1 over 2. Okay, the ratio of corresponding sides, let's just pick, again, we pick the width over the width. That should be 1 over 2, or I'm sorry, 2 over 4, which simplifies down to 1/2. Okay, when we talk about the perimeters, what was the perimeter of A? What was the perimeter for A? 10, so I don't know why they wrote this here, but this should be 10. What's the perimeter for B? 20, okay, good. So 20, that simplifies down to 1/2. What's the area for A? 6. What's the area for B? 24. And all of a sudden we get an answer of 1/4, okay? This does mean something. It might not mean something to you right now, but when we do this, these answers of 1/2, 1/2, let me just write these, circle these again. 1/2, 1/2, 1/2, and then 1/4. They do mean something specific. Okay, let's go through one more just to make sure that we know this. We talk about the width of A is 2. What's the width of C? 6. When we simplify that, that'd be 1/3. Okay? If we talk about the corresponding sizes, it'd be 2 over 6, which would also give us 1/3. What's the perimeter of, let's see, the perimeter of A is 10. What's the perimeter of C? 30. So again, that simplifies down to 1/3. Huh, that's kind of weird. 1/3, 1/3, 1/3. And the areas, let's see, we have 6 for this one. What's the area? Is 54. When I simplify that, that's going to be 1/9. Okay? Don't try to draw any conclusions yet. What I want you to do is try to look at this to see if you notice something as you go on. I do want you to take your time and fill out these next 3 as well. I'll try to do it myself. I don't have it in front of me, but I'll try to do it myself. Okay, hopefully you have gotten this chart taken care of here. Let's just go through this, starting with A over C. That's 1/3, 1/3, 1/3, 1/9. We talked about that. For A over D, did you get 1/4, 1/4, 1/4, 1/16? Okay. Part A over E was at 1/5, 1/5, 1/5, 1/25. And then lastly, 2/3, 2/3, 2/3, 4/9. Is that what you guys had? Okay. What did you guys notice as a pattern? Do you notice any sort of pattern? So these are all the same, right? So the first 3 are the same. So your scale factor is going to be equal to your ratio of the corresponding sides, is going to be equal to your ratio of perimeters when you have similar figures. Okay? And the ratio of areas is different, right? Is it related or not? Is there some sort of relation? Well, it's not, I mean, this, okay. So squaring it, right? Okay. So this is 1/3. This is basically 1/3 squared, right? Equals 1/9. This is 1/4. So this is going to be 1/4 squared. That equals 1/16. This is 1/5 is the ratio of the sides. So when we square, that's 1/25. Again, 2/3. 2/3 squared does give us 4/9. So that's it. Okay. So anything that's one-dimensional is going to be the same. Then something that's, oh, look at this, two-dimensional is going to be squared. Okay? Also, what are our units on this? These units are actually going to be units squared. These are just kind of units to the first power. So 1D to the first power, it's going to be normal. When we have 2D, we have something squared here and something squared here. Kind of a nice way to remember that. Okay? So let's look at this again. Let's just formalize this. It says, what can you conclude about the relationships between the scale factor and the ratios of perimeter? What can you do about the scale factor and ratios of perimeter? What are they? Scale factor and ratios of perimeter. Equal. Fantastic. Okay. If the scale factor of 2 similar figures is A over B, then the ratio of perimeters is going to be what? Well, A over B. Done. Okay, because they're the same, right? They're equal. Awesome. Next one. What can you conclude about the relationship of scale factor to the ratios of areas? Okay, so the ratios of areas are the square of the scale factor. And it's really nice that there's a example below. It says if the scale factor of 2 figures is A over B, if the scale factor is that, then our ratio of areas would be A squared over B squared. Okay, we have to square both of them. Or if you were to put it in parentheses, that's A over B squared. Either way, it's technically correct. I usually think of it like this, but when I write it, I always write it like that. So I don't know. Whichever way works, works. Okay. So let's draw some quick conclusions here in this last slide. Does anyone have any questions on this? We kind of figured it out. Scale factor of 2 triangles is 3/5. What is the ratio of perimeters? 3/5, piece of cake. What's the ratio of areas? Well, we'll just do 3 over 5 squared. So what's 3 squared? 9. 25ths. Done. If the scale factor of 2 triangles is 2/7, what's the ratio of perimeters? Okay, 2/7. Same thing. Ratio of areas. You're just going to square it. that'd be 4/49ths. Again, if you could simplify that, you would, but we can't, so we shan't. The ratio of areas, okay, it gives us something different, is now 25/16ths. Okay, what is the ratio of sides? We're working backwards now. Okay, this would be 5/4 because we're basically doing the square root of both of those. Okay, if the measure of one side of the small triangle is 6, the small triangle is 6. Find the corresponding side of the large triangle. Well, all we'll do is we'll say, hey, that's 5/4 equals, is 6 going to be on top or bottom? Because 6 is the small triangle. Let's see. Looks like this is the large triangle over small triangle. So 6 is on the bottom. We'll put an x there. We'll just cross multiply. That'd be 30 equals 4x. Or x equals, when we divide by 4, that'd be 7.5 units, whatever it's going to be. We'll do that. Okay. For your homework, what they're going to do is they're going to mix this up a little bit. They'll give you something like this units. You actually have to find the scale factor. Sometimes they'll give you the areas of things, and you have to figure it out. You're using this concept back and forth. You will have to apply it a little bit. It's not going to be exactly the same as what we just worked on. If you have questions, make sure to let me know, but you will have some time to work on this as well as advisory today.